Hey, this is the Chapter 4 practice test, multiple choice number 2. So we've got a block of mass 3m hooked up to a rope that goes over the table and passes a frictionless pulley attached to a mass m. We want to know the acceleration of the descending block. Well, the acceleration should be the same for both, by the way, but yeah. Okay, so this is supposed to be a multiple choice, so you really want to do this as quick as possible, but I'm going to do it real slow and explain everything as we go. So I'm going to do free body diagrams. So one of these has a mass of 3m, the other has a mass of m. Okay. For directions, let's see, I'm going to make this positive x here, and if to the right is positive x for the thing on the table, as this thing moves to the right, m will move down, so I need down to be positive. If right is going to be positive for the tabletop, down needs to be positive for the hanging object. For this one, it doesn't really matter what you do for y, because the box will not be accelerating in that direction. So I'm just picking those. Okay. All right. Forces. Well, there's no friction, so the only horizontal force on the 3m block is the tension of the rope. I do have normal force and gravity, however, those aren't really necessary for this problem since they're going to cancel out. For the M block, that is important. I've got gravity down, so mass times gravity, and tension force up. Okay. So, Newton's second law says this. For the thing on the left, in the x direction, I've got T for the net force equals mass is 3m, and then A, I don't know. Okay. Then for the box on the right here, I've got in the positive direction, I've got mg, so I'm going to have mg. I've got t going up, so that's negative, equals the mass is just m times a. I'm going to put this t over in there. That gives me mg minus 3ma equals ma. If I add 3ma both sides, what I get is mg equals 4ma. M's cancel out, and then solving for a, it gives me that a is g over 4. Okay, so that is B on here. That is the acceleration of the descending block.